session we are going to move on to mode data type 3, trying to find the mode of data type 3. So from the definition of the terms, right, of this particular tool, finding the mode, we are trying to find the item that appears the most, right? So here we are going to be dealing with a class. As we said, data type 3 is associated with classes and the frequencies, right? But then when we are trying to find the mode, we are looking for the individual item, that item that appears the most in the entire class. So we are not going to talk about the response is not going to be a class, but the response is going to be one particular value from the entire class. But first, how do we find the mode? So we are going to use the example that we were using in the previous session. This is what we have. So this is a typical data type 3, and we are trying to find the mode of this data type. Last session we tried to use this as an example to find the mean. Now let's try to use it and find the mode of data type 3. So we said mode is the item or the class that appears the most, right? So basically, if you look through the frequencies here, the last one is a total. So the frequencies from here to the down here, we see that the greatest one is 41. 41 is the greatest. Let me get 41 is the greatest. So the greatest one is 41. Yeah. So if it were data type 2, we'll just pick the item, right? But then we cannot pick a range of items. Like 25 to 29 is a range. It's not a value, a particular value as an item. So we need to find a way to find the individual item that is within that class that is actually the mode. So what we have here, the greatest frequency, the greatest item only leads you to the, instead of leading you to the modal item, it leads you to the modal class. So the modal class. So you first find the modal class. So yeah, the mode is the item with the greatest frequency, right? So we have 41 being the greatest, and then it leads us to a particular class. The class, because we are dealing with data type 3. So the modal class is 25 to 29. Yeah, so within 25 to 29, we are not looking for the modal class, but the mode of the data. So the mode is going to fall within these guys. The mode is going to fall somewhere between 25 to 29. So we need to find that item. How do we find that item, that particular item that is going to fall within that class? We are not looking for the range. We are looking for a particular item within the class that is actually associated with the 41. Okay, so we are going to do some modifications, right? Definitely the modal class is definitely going to start with 25. We are going to start with 25 and move towards, add something to it, right? You are going to start here because the mode is falling within this range. So we start with this. We're going to start here and moving towards 29, and we add something to it. We are going to add something to this starting value to fetch the item that fall within this range. So we need to add an item here, right? So we need a starting point. The start is the lower class limit, and then the upper class to the upper class. But then we don't reach the upper class. We have to find a way to add something to the starting point so that we can fetch the item that fall within this range. So we'll start from the beginning, add something to it to get to the item that we are actually looking for. So this changing item is what we have to evaluate to add to the starting point. But yes, I say we are going to start with the starting point, but the starting point is not going to be a class limit. We need to change everything to class boundary. We are going to work with class boundary this time. Remember how we said how to find the class boundaries? Yes, if you don't, please go back and watch how we try to find the class boundaries. So if you find the class boundary, so let me do all here. But in the case of finding the mode, we just need the class boundary for that class. So let me do class boundary in this case. So this is class boundary. So what do we say? So the difference between this and this is 1. So here I'm going to have 9.5 to 14.5. Here is going to be 14.5 to 19.5. So the next one is going to be 19.5 to 24.5, and then this one is going to be 24.5 to 29.5. Don't just be doing this alongside. Make sure you watch our video, the previous ones that explains how to find these items. Right? Don't skip them, because each is built. We took our time to explain each of them for you, so they are very necessary for you to understand. So this is 29.5 to 34.5. So now the modal class, instead of using this modal class, right, we are going to use this class, because the modal class, this is in terms of class limit, but we want it in terms of class boundary. So it is in 24.5 to 29.5. This is the class boundary that we have. So now our starting value for this particular class is actually going to be 24.5. Yes, so it's going to be actually be 24.5. That's what we actually have to start with. And I say we are going to add a particular item to this guy. We are going to add a particular item to this guy. So if you move to 24.5, we add something to it to get to the value that actually corresponds to the mode. It is within this range, but we need to start and add something to it to reach the actual item that is the mode itself within this range, right? But then how do we find that? So we are going to find that changing item to add to our thing. So but that changing item fall within the class, right? So we need a particular fraction of the size class. So we also need another tool called the size of the class. So I need size, the size of this class. Let me call it C. The size of this class is size C. So how do we find the class size from the class boundary? We did that to 29.5 minus 24.5. If you do this, yes, you are getting 5. So we got 5. This is our class size. So now why are you even finding class size, right? So the entire class from 24.5 to 29.5 is 5, right? Remember, we are starting with 24.5 and we want to add a particular value to the starting point to get to the actual value that is the mode within the range. But then we need to make sure that we don't add something that is outside of, that goes beyond the class, right? So we need to limit to the size of the class. We need to make sure that whatever we are going to add is limited within the size of the class itself. So that's why we need the class size, so that whatever we are adding doesn't go beyond 29.5. So we need to use the class size and take a portion of the class size and add to the 24.5, so that we know that we are fetching a particular item that falls within the class and corresponds to the actual value. That's why the class size comes in. Fine. So now I said that we need to fetch a proportion of the class size, to add to the. We need a proportion of the class size to add to the our lower class value. So you need that proportion, right? So we know the class size. So we need a proportion. A proportion means like a fraction, a percentage of that. But then, so that's when this thing comes in. There's a proportion, right? That 1 change 1 over change 1 plus change 2. Or this is a proportion component that will multiply our class size. So we're having our class size and we are using this particular line to fetch a proportion of it to match, to fetch a proportion of the class size and add to our starting value. Now, what is change 1 and change 2? Change 1 and change 2. Change 1 is the difference between the frequency. This is the frequency, right? Our frequency 41 minus the lower class, the class before the class boundary. So the class before the modal class, right? We have 41. The frequency of the class before is 27. Then if you are doing theta 2, is the opposite. Is 41 minus the class after. The frequency of the class after is 30. That's what we basically do. So 41 minus how do you call it? 27, right? 27, right? We are going to get I don't have my calculator here. Let me see. 41 minus 27. So we have if you do this difference, we are going to have 4 here, 14. So you get 14. Now if you do this difference, 41 minus 30, definitely we are going to get 11. So basically this is what we have for our class changing 1 and changing 2. they are going to help us. These changes are going to help us fetch the proportion of the class size so that we can add that particular result to the starting point. So now changing 1 over changing 2, this one now becomes, so change 1 is 14 over 11 plus 14, all times our class size is what? 5. So if you do this, we are going to add, let me calculate that quickly for you. So yeah, basically, like, try to follow the concept, right? I'm trying to get my calculator on for you. So try to get the concept why we are doing this. That's the most important part of the whole process, right? It's good for you to take time and understand all these things so that when you move forward in your academic ladder or university, you understand what you are doing. It's about understanding, right? Yeah. So we have 14 divided by 11 plus 14. So this is what I have. So I have 0.56 for that. So 0.56 times 5 is giving me 2.8. So from here I got 2.8. You can verify from your end, right? I got 2.8. So now our mode is going to be our starting point, which is 24.5, plus the fraction of the class size, which is 2.8, sorry. So if you add, so 24.5 plus 2.8, they are having 27.3. So the mode for this particular class, right? So the mode for this particular data is 27.3. Is this guy? That's the value. So generally speaking, if you want to find the mode, right? Let me write the formula for you here. If you want to fetch the mode, so mode is equal to lower class boundary, right? Lower class boundary plus a proportion of the class size. So for that proportion of the class size is changing 1 over change 1 plus change 2. You are fetching a proportion of the class size. So where change 1 is equal to frequency of the modal class minus frequency of the class before, and then theta 2 is frequency of the modal class minus frequency of the class after your modal class, right? So first your modal class and focus on that modal class to fetch the class boundary. So that will be the lower class boundary. Get the lower class boundary. We don't work with the class limit. That's why I said it is very important that when you have a data type 3, just try to make sure that you get your class boundaries table sets added to it, so that in case you need it, you just quickly refer to that, right? So yeah, mode. This is the basic formula for the mode. This is the basic formula for the mode. And as usual, in the next session, right, we are going to use another example to also illustrate, to just solve. We are going to solve an example on how to find the mode of a data type 3 again. So I hope that this session has helped you, and then you will be able to use that to go through your textbook and see how these things relate. You see that we didn't use frequency in this case, right? We're trying to find just the mode quickly. Yeah. So kindly go to this session again, watch the video, make sure that things concept, and then follow me in the next session where we are going to solve an example related to how to find the mode as usual. And then from there, we take the median from there in the subsequent sessions. See you in the next video.